In our previous classes, we discussed in detail on the first components of concrete called paste, particularly on cement. Today, we are going to discuss on the second major component of concrete called aggregate. Aggregate is one of the ingredients of the concrete which made from the parent rocks, which are igneous rock, sedimentary rock, or metamorphic rock in different ways. Then there are two sources of aggregate: natural sources and artificial sources. Natural sources are natural rivers, natural lakes, and others. We get the fine aggregate sand and the coarse aggregate gravel pits and others from these natural sources. The artificial source of aggregate, therefore we use the cobbles or stones or rocks at the raw material, and the machine crushes the raw material at the required size. Therefore we get the fine aggregate and the coarse aggregate artificially. In general, the aggregate occupies a minimum of 70% of the total volume of the concrete. This means it is the major components of the concrete. Therefore, it has the vital role in the concrete. Role number one, because of its large volume in the concrete, okay, it is the filler material of the concrete. We use at the filler material. The second role is it gives strength to the concrete. The strength of the concrete highly depends on the strength of the aggregate. Therefore, aggregate is the major components of the concrete. In terms of size, we classify the aggregate into two major groups: coarse aggregate and fine aggregate. Coarse aggregates are aggregates which have a size greater than 4.75 millimeter. And fine aggregates are an aggregate which have the size less than 4.75 millimeter. Therefore, 4.75 millimeter size is the boundary of fine aggregate and coarse aggregate. The special tool sieve number 4 differentiates the aggregate into coarse and fine. There are a number of holes in this sieve. Its mesh have the standard size of 4.75 millimeter by 4.75 millimeter opening. Therefore, all aggregates which pass through this sieve number 4 is called fine aggregate, and the aggregate which retains on this sieve number 4 is called coarse aggregate. Therefore, 4.75 millimeter is the minimum size of coarse aggregate, and it's also the maximum size of fine aggregate. For concreting purpose or for most concrete works, 20 millimeter aggregate size is recommended. But it is possible to use the aggregate having a size greater than 20 millimeter for the concrete. The maximum size of aggregate for concreting purpose is 80 millimeter. It's the maximum size. Not possible to use an aggregate having greater than 80 millimeter for concreting purpose. Therefore, it's possible to use the large aggregate size if the precondition fulfills. The first precondition is the size of the structure is adequate, or the thickness of the structure is adequate or large. At least the maximum size of the aggregate is 1/4 of the thickness of the structure. For example, if the thickness of the structure is 100 millimeter, the maximum size of aggregate that we use for this structure is 100 by 4, it's 25 millimeter aggregate. If the thickness of the structure is 200 millimeter, 200 by 4, it's 50. Therefore, the maximum size of the aggregate for this structure is 50 millimeter. Impossible to use greater than 50 millimeter, but it's possible to use less than 50 millimeter. This is the first precondition. The second precondition is the spacing between the reinforcement bar is adequate for using this large size aggregate. If these conditions fulfill, it's possible to use the large size aggregate for concreting purpose, but the maximum size is 80 millimeter. I think this is the general concept of aggregate for concreting. We will see in detail in our next videos. Thanks a lot for watching this video. This is your choice for deep engineering knowledge. This is Ashu Engineering.